Okay, here's a nice problem that we're familiar with, except now we're throwing in friction. So we have a mass M1 resting on the surface. It has a string attached to it, passed over a pulley, and attached to mass M2 that is hanging there. And there's friction between M1 and the surface of mu. And let's assume that it's actually moving and accelerating. So that would be the kinetic coefficient of friction between the two. And the question may very well be something along the lines of find the tension in the string and the acceleration of the system in terms of m1, m2, mu, and g. Okay, so, or sometimes you'll get things like find it in terms of m1, m2, mu, and any other universal constants can be used, that sort of stuff, which g would be one of. Alrighty, so let's look at this. If this is indeed moving, then it's clear that, and it's accelerating, then it's clear that m1 is accelerating to the right, and m2 would be accelerating downward because friction wouldn't actually pull it up the other way. It might keep it from moving, but it's not going to actually work in the opposite direction. It's not the way friction works, which is a good thing for us. All right, so what do? Well, to find the acceleration, I'm going to look at the entire system. But note that on this end, well, let's do free body diagrams. So for M1, I've got downward its weight, which is M1G. Upward is the normal force, which is going to have to equal M1G, so they're equal and opposite. To the right, we have tension. To the left, we have the friction force, which is equal to mu k times the normal force, which is equal to mu k m1g. That's the friction force. Over here, for m2, it's a little simpler. Downward, we have m2g. Upward, we have the tension in the string. So if we look at the entire system, so looking at the system first, SYSTEM, there we go. The total mass is m1 plus m2, and it's accelerating at a. So that acceleration is equal to the net force divided by the total mass. Now what forces are pulling on the system? In the direction of the acceleration is m2g. In the opposite direction of the acceleration is the friction force. So that means that we're going to have, in the direction of the acceleration, we're going to have m2g, so that'll be positive because it's with the acceleration. In the opposite direction, so minus, and I'm going to rewrite that just a little bit, m1 mu kg divided by m1 plus m2. And so I can actually factor out g if I want to. Sometimes you'll see it written like this. So g times m2 minus mu k m1 over m1 plus m2. And there's your acceleration, if indeed it exists. And since it's moving, we'll assume that it is. If it's moving, and I guess it's possible that the friction equals the weight of m2, in which case it would be moving at a constant velocity. But we will assume that the two accelerations are equal. Okay. So now, how do we find the tension? Well, I'm going to do it one way, and then you can do it the other way and convince yourself or show yourself that you'll get the same value in both cases. I'm going to use I'll do the simpler one right here. I'll let you do the slightly more complicated, only because it's got these other terms. So let's see here. So for mass 2 now, not the entire system, just mass 2. We have the net force acting on it is equal to its mass times the actual acceleration. And the net force in this case is m2g minus the tension equals m times a. And I actually have to use this whole big thing up here for a, because notice up here, there's nothing in terms of a that we can leave our answer. Answer has to be in terms of m1, m2, mu, and g. Okay. Which means, now just solving for t is going to equal m2g minus ma. So that means M2G minus M2 again, because that's all M2, times G times M2 minus mu K sub K, sorry about that, M1 over M1 plus M2. And you could probably leave it like this, although if you're looking at, if this is something in the answers in the back of the book would be tidied up a little bit, and the final answer in the back of the book might look something like this. So a bunch of steps, one, two, dot, 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 bunch of steps in the middle, and then your final answer would be M1, M2G times 1 plus mu over M1 plus M2. And that equals your tension. So, and I will leave it to you to work with the mass 1 equation and see that you can indeed get exactly that same answer.